Welcome back. So, in the last lecture I talked about interest rate risk and I also discussed the various measures of interest rate risk that included DV01 or what we call the dollar value per basis point. Then we moved over to Macaulay's duration, then modified duration and finally interest rate elasticity. These are the four common measures that we use for assessment of interest rate risk of a bond portfolio. Of these, the cardinal measure is the Macaulay's duration, and continuing from where we left off in the last lecture, I will now illustrate this concept of duration and the dynamics of bond investment with an example. So, for that purpose we consider a 12% annual coupon bond of the face value of rupees 1000, which is also its redemption value. It is redeemable at par at the end of 25 years from now. So, let me repeat, it is a 12% annual coupon bond, coupon payments are annual and the face value as well as redemption value is 1000 and the bond has 25 years to maturity. The T equal to 0 interest rates YTM are 16.65%. This figure seems unusual, but the rationale behind it will be apparent in the next sentence. At this YTM, the current market price of the bond is 726.66 and the duration is 7 years. You get a whole number for the duration. That was the objective behind choosing 16.65% as the interest rates. So, this is the basic data on which we build upon in the following slides. It means that for y equal to 16.65%, which is the YTM of the bond and a holding period of 7 years, the first derivative of total cash flows, which is a function of y, and the holding period, which is a function of the YTM as well as the holding period with respect to y will be 0. This was the definition of duration. This was how we arrived at the fact that if you hold a bond for its duration, you are immunized against small changes in interest rates. We equated the first derivative of the total cash flows to 0 and then on simplification we arrived at the expression for the duration. So, if the duration is 7 years, that means the first derivative with respect to total of total cash flows with respect to y will be 0 for this holding period. This means that the total cash flow value that we get, that is 2135.63, which we work out the total cash flow value for a period of 7 years, for a holding period of 7 years and at the interest rate of 16.65%, you get the total cash flows of 2135.63 and this 2135.63 is independent of small changes in interest rates around 16.65%, since the derivative is with respect to the interest rates. You can see here explicitly also in this table what I have done is I have worked out the total cash flows corresponding to different interest rates for the same bond for a holding period of 7 years. So, it is these cash flows correspond to a bond which has annual coupons of at the rate of 12%, face value of 1000, redemption value of 1000 and maturity of 25 years, the holding period is 7 years. The total cash flows are computed at the end of 7 years corresponding to different YTMs, different reinvestment rates. As you can see here, if the interest rate is 11% for on the basis of which we compute the total cash flows, we find that the total cash flows turn out to be 2251. If it is 12%, 2210 and so on. The entire table is given in the bottom panel. Now, there are two fundamental things which we note immediately from the figures that we have here. The important thing is that around this figure of 16.65%, what we find is that if there is small change in the interest rates, let us say from 16.65%, around 16.65% from 16% to 17%, the total cash flows change from 2137 to 2135.94, that is a marginal change of 1 unit of money. However, if you observe a similar change of 1% from 11% to 12%, the change is from 2251 to which is a 41 money unit change. So, the important point that I want to bring to the learners and that I strongly emphasize here is that around the point at which the derivative turns out to be 0, that is the 16.65% point here in this example, what we find is that if there are marginal changes either to the left or to the left, the total cash flows remain literally unaffected. That is one thing. The second thing that we observe from this table is that the total cash flows at this point of 16.65% interest rate turned out to be minimum of all total cash flow values that we have in this table. The total cash flows at 16.65% is 2135.63, whereas if you look at any other value in this table, it is above this figure. So, these are two important observations. The reason behind the second observation, or the rationale or the finance sense behind the second observation is that notwithstanding the fact that it has the lowest cash flow, it also has the minimum variability. So, this is compatible with our usual assumption that minimum the risk and expected return move in tandem. Higher the risk, higher the expected return, lower the risk, lower the expected return. So, because the variability in cash flows around this figure of 16.65% is minimal, naturally we expect the expected returns to be lower, and that is vindicated by the figures that we saw in the previous table, where we saw that around 16.65% in the total cash flows turn out to be minimum. So, let me read these points to you once again, and there are two things worth noting here. The interest rates close to the YTM, that is 16%, for example 16% and 17%, the variation in cash flows is very small if the bond is held for its duration, that is 7 years. We have the minimum total cash flows for the holding period equal to its duration, that also I explained. This is the way it should be, because duration constitutes the minimum risk holding period in the sense that the curve is flattest at this point. The curve between the interest rates and the and the total cash flows is flattest around this point of 16.65%. Therefore, minor variations in the interest rate do not manifest themselves as variations in the cash flows, and variation in total cash flows is minimum around this point. Now, let us investigate the dynamics of the bond investment further. That is very interesting. Let us say that A has bought the bond at t equal to 0 at a YTM of 16.65%, which is the current interest rate. I repeat, A buys the bond at t equal to 0 when the market interest rates are 16.65%. The current price of the bond turns out to be 726.66 at which he purchases the bond. Redemption is at face value, but we shall be holding the bond for a period of 7 years. But if A has made the investment at t equal to 0 in this bond, 12% annual coupon bond, maturity 25 years at the current market price of 726.66 when the interest rates are 16.65%. Then if the interest rates do not change over the whole over the life of the bond, then A will get a return of 16.65%. A will get an annual yield of 16.65% if interest rates do not change. This is important. If interest rates do not change subsequent to its making of the investment, A gets a return of 16.65% per annum. If interest rates do not change, the t equal to 0 investor, that is A, earns a return of 16.65% if all the coupons are reinvested at the YTM of 16.65%, and either he holds the bond to maturity or he liquidates the bond at an earlier date, whichever earlier date it may be, but at a price which is computed with a YTM of 16.65%. Let me repeat, if interest rates do not change, then t equal to 0 investor A will earn a return of 16.65% per annum if all the coupons are reinvested at the YTM of 16.65%, and the price at which he liquidates the bond if he does not hold it to maturity. Of course, if he holds it to maturity, it is a different matter, he gets the redemption value. But if he does not hold the bond to maturity, he liquidates the investment earlier than maturity, then the price at which he liquidates the bond turns out to be 16.65% at the rate of 16.65%. If both these conditions are satisfied, reinvestment at 16.65%, sale in the market, liquidation in the market at a YTM of 16.65%. If both these conditions are satisfied, then A will get a return of 16.65% irrespective of his holding period. In other words, irrespective of the holding period, provided all coupons and the sale price are calculated at 16.65%, he gets a return also of 16.65%. What if interest rates change? What happens if interest rates change? Obviously, the price at which the investment has been made by A, that is P 0, that is the price at t equal to 0, is fixed, being the price at which A has bought the bond, which is 726.66. If A holds the bond for t equal to d equal to 7 years, which is the duration of this bond, his total cash flows at t equal to 7 years is immunized against changes in interest rates. Thus, any small change in interest rates will not change the total cash flows at t equal to 7 years, that is the duration of the bond. So, if you hold the bond up to its duration, then you will get immunized against any changes in the total cash flow due to changes in interest rates. This means that the cash flows at t equal to 0 and t equal to 7 are both fixed. T equal to 0 cash flow is obviously fixed, because that is the investment that is made for buying the bond, that is the known cost, that is in a sense that is a cost which has already been incurred. So, there is no randomness attached to it. And then what we find is that if we hold the bond to t equal to 7 years, then the total cash flows become independent of changes in interest rates, at least to some extent. Therefore, the total cash flows at t equal to 0 and t equal to 7 years both become independent of interest rates, and that means what? And that means that the return over the 7-year period will also become independent of changes in y, changes in interest rates, if A holds the bond for 7 years. Bond dynamics if interest rate changes. Let us assume, let us now delve further into the bond dynamics. Let the interest rate change to 17% on day t equal to 1. The investment is made at t equal to 0 by A at 16.65%. At t equal to 1, that is 1 day after making the investment, the interest rate change from 16.65% to 17%. The price of the bond will change from 726.96. What is this figure? This figure is the t equal to 1 day price at 16.65% to 712, which is the t equal to 1 day price at 17%. I repeat, this is very important. Due to the change in interest rates, immediately following the change in interest rates, what will happen is that the bond price, because there is an increase in interest rates, the bond price will fall. It will fall from the price corresponding to 16.65% with a maturity of 24 years and 364 days, that is at t equal to 1 day, and that turns out to be 726.96. From this figure, it will drop down to 712, which is the t equal to 1 day price, that is for a bond, 12% bond with a maturity of 24 years and 364 days at a YTM of 17%, and that turns out to be 712. So, there is a fall in price corresponding to an increase in interest rate from 16.65% to 17%. The price has changed from 726.96 to 712. If B buys the bond at t equal to 1 day at 712, that is after the interest rate change, he will get the YTM of 17%. If all future coupons are reinvested at the rate of 17%, and either he holds the bond to maturity, or if he liquidates the bond, he liquidates the bond at a price which is calculated at a YTM of 17%, as was the case in A's holding. However, if A liquidates his investment on day t equal to 1, what happens to his situation? He loses out significantly. The investment that he had made at 726.66 is now being liquidated at 712 because B will pay only 712 for buying the bond at a YTM which is equal to the current market interest rate of 17%. So, A loses out or the loss of A that occurs because of its 1 day holding and because of the change in interest rate from 16.65% to 17% is 2.02%. So, in 1 day he has lost 2.02% of the value of his investment due to this change in interest rate. But important thing is, because why has he lost this much of money? He has lost this much of money because he has not held the bond up to 7 years, has not held the bond up to its duration. Had he held the bond up to its duration, notwithstanding the price change from interest rate change from 16.65% to 7.17%, he would still have made a return or have earned a return of 16.65% if he had held the bond for 7 years. That is the importance of duration. Let me repeat this sentence again. The important thing is, why has he lost this amount of money 2.02%? Because he has held the bond only for 1 day. Had he held this bond for 7 years, then notwithstanding the fact that the interest rates have increased from 16.65% to 17%, he would still have earned a return of 16.65%. Why is that? You see, when he liquidates the investment at t equal to 1 day and the interest rates have risen, the price at which it is the new price or the price at which the bond is sold is calculated on the basis of discounting all future coupon payments and the terminal redemption value at the higher rate, that is 17%. So, this 17% operates for a sustained period of time over 24 coupons and the final price or the final redemption value. And had he held the bond for 7 years, what would have happened? He would have reinvested at least 6 of the coupon at t equal to 1, coupon at t equal to 2, t equal to 3 up to t equal to 6 at the higher rate of 17%, which would have compensated him for some of the loss that he would have incurred due to the fall in the market price of the bond corresponding to the change in interest rate. And secondly, when we work out the market price also at t equal to 7 years, the fall will not be so gigantic. Why? Because the number of coupons and the terminal value that needs to be discounted to work out the value at t equal to 7 years is less compared to what we have at t equal to 1 day. So, if A had held the investment for 7 years, his cash flows after interest rate change to 7% would have been 2135.92. That is a return of almost exactly same as his originally anticipated return of 16.65%, as I explained. If A's holding period was 7 years, then due to the increase in rate from 16.65% to 17%, A would have reinvested coupons at this higher rate for a longer period, t equal to 1, 2, 3, 4, 5, 6, 7. If A has liquidated the investment at t equal to 1 day, he gets no opportunity to reinvest his coupons and take advantage of the increase in interest rates. However, the increase in interest rates manifests itself by discounting all future cash flows, and there are 24 of them. 25 of them rather, which need to be discounted at t equal to 1 to t equal to 25, which need to be discounted. Had he held the bond for 7 years, then out of this 25 cash flows that need to be discounted, 7 of them would not be discounted and only 18 of them would be discounted at the higher rate, and at the same time the coupon payments at 1 to 6 would be reinvested at the rate of 17%, the higher rate. So, there would be a significant annulment of the capital loss due to the interest rate increase by the reinvestment income. That is the important thing. A would have reinvested coupons at this higher rate and hence got higher interest on reinvested coupons. The capital loss suffered by A would have been reduced because the number of discounting periods at the higher rate of 17% would have been less. For holding period of 7 years, these effects cancel each other, these effects annul each other exactly. Thus, notwithstanding the small change in interest rates, his return would remain unchanged if he holds. This is the catch. This is the fundamental thing. If he holds the bond for 7 years, but he did not hold the bond for 7 years, he held the bond for only 1 day, and that is the reason that he lost an amount as significant as 2.02% of his investment value. However, the price of the bond at t equal to 1 day will readjust, so that over the remaining period, that is t equal to 1 day onwards, the bond provides a YTM of 17%, because the bond has to give you a return which is commensurate with the market rate of interest. You cannot have a situation where the bond gives you a different rate of interest and the market wants a different rate of interest. That will not be a stable equilibrium. You see, at equilibrium, it is necessary that the bond gives you the same rate of return, the same YTM or the same yield as the market rates of return, corresponding of course to the same risk class. It is important that the two rates, in order that they be comparable, be defined with respect to the same risk class as the bond. The market rates must be compatible with the risk class of the bond that we are talking about. In other words, if another person B buys the bond after the change in interest rates from 16.65% to 17%, that is, after t equal to 1 day, he will get a return of 17% and not 16.65%. That is why the price had gone down. You see, after the change in the interest rates, whosoever has entered the investment, whosoever has made the investment at 17% market rates has to get a YTM of 17%, and because the maturity value is fixed, the only thing that can change is the price of the bond. The price of the bond readjusts itself such that if you buy the bond at t equal to 1 day after the change in interest rate to 17%, you get a YTM of 17% over the life of over the remaining life of the bond, that is 24 years and 364 days, if the interest rates do not change again, of course. So, let me read it out once again. In other words, if another person B buys the bond after the change in interest rate from 16.65% to 17%, that is after t equal to 1 day, he will get a return of 17% and not 16.65%, and he can only get that by the falling or the reduction in the price of the bond at t equal to 1 day after the change in interest rate. Everybody will demand 17% return, the demand for the bond will decline, and therefore, the price will decline. Thus, if A, who bought the bond at t equal to 0 when the interest rate was 16.65%, sells it to B after the interest rate changed to 17%, that is at the end of t equal to 1 day, he will not get the yield of 16.65%, but a lower yield. It so happens that the yield turns out to be minus 2.02%. The return turns out to be minus 2.02%, but A did not hold the bond for its duration. What about B? B takes the bond at 17% after the interest rates have changed and t equal to 1 day. He will get a YTM of 17% if the usual conditions are satisfied. What are those conditions? The conditions are that all the coupon payments are invested by B at the rate of 17%, and either B holds the bond up to its maturity, or if the bond is liquidated earlier, the price at which it is liquidated, the price at which it is sold in the market is at the rate of 17% YTM. So, if both these conditions are satisfied, Y will get a return of 17%. There is another interesting feature about Y. Now, as far as Y is concerned, if Y holds the bond for 7 years, does he get immunized? It does not get immunized. Why? Because Y has bought the investment, Y has taken up the investment at a YTM of 17%, and if you work out the duration at the rate of 17%, it is not 7 years, it is not 7 years, it is how much? It is about 6.90 years. So, in order that Y immunizes himself against further changes in interest rate, he should not hold the bond for 7 years, he should hold the bond for 6.90 years. Let me repeat, because you see the duration is Y dependent, the duration depends on the YTM. Now, the point at which B enters the investment is at a rate of 17%. The figure of 7 years that we had calculated for the duration was at 16.65%. So, that 7-year figure will not hold for B. For B, you have to work out the duration again at 17% and you find that it is 6.90 years. Therefore, if B is to immunize himself under this philosophy, he has to hold the bond not for 7 years, but for 6.90 years. However, if interest rates change, he will not be immunized if he holds the bond for 7 years. This is because the duration at 17%, that is 6.90 years, is not the same as that at 16.65%, which is 7 years. Hence, he needs to hold the bond for 6.90 years for immunity. Now, there are certain caveats which I need to refer to quickly. You see, I referred to earlier also in the last lecture, but the basic thing is that the interest rates, the changes in interest rates over which this immunity operates have to be small in magnitude. That is simple, because how did we arrive at this immunization? By holding to duration, we worked it out on the basis of taking the first derivative of total cash flows and equating to 0. That is, in a sense, we worked out the local minima, you may say, and therefore, this minima will hold only for minor changes, for infinitesimal changes in interest rates to the left or to the right. The Newtonian differentiation, you have to keep in mind, the Newtonian differentiation is the first order correction as far as the Taylor series are concerned. First order derivative we consider, we do not consider higher order terms, and in that sense we assume that around this point at which we are working out the derivative, the curve is approximated very well, approximated adequately well by a straight line, as you can see here in this portion. However, if the interest rate change much more, the curvature comes into effect, and the curvature introduces certain deviations or distortions rather, and as a result of which the immunization will not operate when we talk about large changes in interest rates. So, if there is a large change in interest rates, then this independence will not hold, since the flatness of the curve extends only for small regions around 16.65%, as you can see in the right hand panel figure as well. Because duration D is y dependent, if we use a different interest rates, we shall get a different duration. I repeat, and duration is y dependent. This is very important. Another important issue, duration is y dependent. So, if you have a different YTM, you naturally get a different different duration. Thus, if we use a different interest rate for calculating the total cash flow, but calculate the total cash flow at 7 years, we are not calculating the TCF at its duration, and hence the immunity will not hold. For example, you see, if you are calculating the total cash flow at a rate of 11% or 12% or 15%, then the duration corresponding to this 11%, 12% or 15% will not be 7 years. So, if you are calculating cash flow for 7 years using interest rates of 11%, 12% or 15%, you are not calculating those total cash flows at the duration corresponding to the interest rates that you are using for calculation the total cash flows. You have to try to understand that this has to be compatible. The rate at which you are calculating the total cash flows must be the same as the rate at which the duration is calculated. Like the example that I gave you, that if the rate is 16.65% and then the duration is 7 years. So, if you calculate the total cash flows at 16.65% for 7 years, you get immunized. If you calculate the total cash flows at 12% and you calculate for 7 years, there is an incompatibility between the duration. The duration at 12% is not 7 years. Therefore, the immunization does not hold, as you saw in the example, that the figures in the table that I showed a few minutes earlier. Thus, if we use a different interest rate for calculating the total cash flow, but calculate the total cash flow as t equal to 7 years. We shall not be calculating the total cash flows at the duration, and hence the immunity will not hold. This is seen from the example. If we use the interest rate of 11% and we calculate total cash flows for 7 years, we get 2251. However, if the interest rate changes to 12%, the TCF changes to 2210. That is a change of 41 money units. That is quite significant. As I mentioned, if there is a change from 16% to 17%, the total cash flows change by as small as 1 money unit. This is because the duration at 11% is not 7 years, it is 9.25 years. So, if the interest rates are 11%, you need to work out the duration of at 11%, which is 9.25 years, and thereafter you need to calculate the total cash flows over 9.25 years, and then those cash flows will be immunized against small changes in interest rates around that 11% mark. TCF is a minima at duration. I have already touched upon this point. Let me read it out quickly. Because the second derivative of TCF at the rate of 16.65% for 7 years with respect to y is positive, it follows that the TCF is a minimum at this t equal to 7 years for y equal to 16.65%. This also was vindicated by the figures that I showed you in the table. In other words, the TCF will increase on either side of the 16.65% mark for a holding period of 7 years. That is, if the interest rate change, but the holding period remain at 7 years. But the important thing is that the variation in TCF is minimal around the duration corresponding to a given YTM. This is important when we are talking about duration. Duration is not a concept which is basically for optimizing return. It is a concept for minimization of risk, and when you are talking of minimization of risk, you are talking about minimization of variability, and variability is minimal when you hold the bond around its duration, notwithstanding the fact that if you move to either side of it, left or right of duration, the total cash flows will increase. So, TCF may increase at rates other than the YTM of 16.65% for 7-year holding period, but then the sensitivity of TCF to interest rate changes also increases. This is seen below. Suppose the YTM at t equal to 0 is 11% and you hold the bond for 7 years, your TCF turns out to be 2251. If the interest rate changes to 12%, the TCF changes to 2210. Although the TCF is higher than the TCF at 16.65%, the change in TCF, the variability of TCF corresponding to a 1% change in interest rate that I mentioned just now is 41 compared to only 1 for a change from 16 to 17%. The change in TCF is far more than around 16.65%. This is commensurate with the principle that higher expected return for higher risk, lower expected return for lower risk. This is the plot of TCF versus interest rate. As you can see, we have a flat region around this point of 16.65%, and as you move to the left or to the right, the cash flows tend to increase, but the variable, the slope also increases. Here the slope is approximately 0. However, if you move to the left or to the right, the magnitude of the slope increases. That means what? That means the variability in the cash flows corresponding to a given change in interest rate also increases. Duration of zeros, which I will take up after the break. Thank you.